Estimating roots or estimating roots that are irrational is a challenging task. It's going to be tough to do in 2 or 3 minutes. But the key component for you is to know your perfect squares like 1s, 4s, 9s, 16, 25, 36, and so on, and your perfect cubes, 1, 8, 27, 64, 125, and so on. And then you also need to know the relative position of other numbers on a number line compared to perfect squares and cubes. Let me explain that. Now, first off, I should tell you this technique is not perfect. It is an estimate only, and there are other ways to calculate these numbers by hand. That is not what we're doing here. We're estimating. Okay? What we're going to do is we're going to identify the perfect squares that are between, on either end of the number we're looking at. So for example, if I'm looking at the square root of 29, I know that the square root of 25 is the lowest perfect square right to the left of it, and the square root of 36 is the next perfect square to the right of it, which means the square root of 29 is between the number 5 and 6. I can already make a guess as to its 5 point something. And then at this point, I'm going to go ahead and say that there's a 4 number difference here. And there is, what do we got here? A 7 number difference there. So it looks like it's on the low side of halfway, but it's almost halfway. So 5.3 is probably a pretty good guess. If it were more like, if these two numbers were more the same, I'd be closer to 5.5, for example, but they're not. So I'm going to guess 5.3, and I'm going to say that for an estimate, that's good enough. Now, in a cubic root, the concept is the same. We're going to go ahead and establish what the lower cubic root is. The lower cubic root is the cubic root of 64, which equals 4. And the higher cubic root is the cubic root of 125, which equals 5, right? That's the point here, estimating the location of your number on a number line. That's what we're going to do right now. So where is 100 related to this? Now, by the way, square roots work differently than cubic roots, but we're going to use this as an estimate anyway. And since we're estimating, I don't need to be all that precise. This is about 35 or 36 numbers apart. This is about 25 numbers apart, which means it's more than halfway. You'll notice it's closer to the high end. So 4.5 would be halfway. I'm going to be higher than that, so I'm going to guess 4.6 or 4.7. And since the goal here is estimating roots, not calculating roots, I'm going to say that we've successfully estimated the value of those two numbers.